Good afternoon, everyone. Thanks for joining this OPIN webinar called Improving Confidence Through Standardization and Certification. My name is Laura Macadré, and I'm project manager at Iecre in France. So just a couple of indications before we start the meeting. So we're in a webinar, so your microphone will be muted during this event, but you can ask your questions at any time in the dedicated Q&A box, and we will address all questions during the Q&A session at the end of the meeting. The event will be recorded, and both the slides and the recordings will be shared on the OPIN website just after the event. So the aim of the webinar today is to discuss standardization and certification and how they can increase confidence, in particular from investors and insurers. So to do so today, we will start with a very brief OPIN introduction. Then our first speakers will be Michael Bullock and Johan from Renewable Risk Advisors. Our next speaker will be Jonathan Colby from Verdant Power, and he will speak about IEC standardization and certification schemes. And we will finish by a feedback from a technology developer on technology qualification, and this will be presented by Pilar Heras from Floating Power Plants. At the end, we will have 20 minutes dedicated to question and answers. So again, do not hesitate. If you have questions during all the presentation, you can put them in the Q&A box, and please specify to which speaker your question is addressed. Okay, so let's start with a brief introduction on the Ocean Power Innovation Network. So OPIN is an international network dedicated to offshore renewables. The aim is really to encourage collaborations between different sectors, but also between different regions. The network is open to any types of members. They can be companies, small, but also large companies, research centers, public organizations, etc. The network is open to members that are already strongly involved in offshore renewables, but also to other members that are working in other sectors and would be interested to diversify their activities. So we are 7 partners. You can see the logos on the bottom of the slide, and we are strongly involved in the growth and the animation of the network on a daily basis. The partnership is led by SCI in Ireland, and we are the French partner in this project. So we are funded by Interreg Northwest Europe for 4 years until June 2022. And with the 2.6 million budget, we are organizing free activities for the OPIN members. So regarding the membership, today we have about 400, a bit more than 400 members from 30 different countries. So really from all continents all over the world, and we are very pleased of this. So quite a number of our members are still from UK, France, and Ireland, but we still have significant number of members from other countries. And we do have also quite a number of SMEs in the network because we have specific activities that are dedicated to the small and medium enterprises. And obviously, we have also other types of activities for all kinds of members in the network, and the event today is one of the examples. So joining the OPIN network is completely free. It's very quick, only a short form on the internet. So you have here the link, but I do hope that if you are here today, it's because you are already an OPIN member. So now, if you are an OPIN member, how can you benefit from the network? The first way is to access the free events that we organize on a monthly basis. So today is a good example. We are also organizing master classes, so they are more like trainings. We are also organizing annual symposia. And as you can see, since the beginning of the project, we organized a bit more than 30 events on a wide variety of topics. So they can be material, mooring, funding, testing, and also synergies with other sectors such as aquaculture, oil and gas, etc. So if you're a member of OPIN, and in particular for the SMEs, you can benefit from an expert advice on the technology or the product that you are developing. So we call this a technology assessment process. We can also support working groups within OPIN. So we call them collaborative innovation groups. And this is open to any type of member within OPIN. So for instance, we currently have an ongoing working group on corrosion. We have another one on floating solar. And what is interesting to be noted is that the topics are completely open. So as OPIN members, you can suggest your own topics depending on what you would like to be addressed collectively as a group. So we have a very short application form that you can fill to suggest a new topic for a working group. And finally, the Irish and Scottish SMEs can receive travel support to travel for OPIN events. So this was not so relevant over the past months, but we do hope that we will organize again in-person events, in particular from the beginning of 2022. So do not hesitate to contact us at opin@iecre.ie if you have any questions on these services, and you can also contact me personally. Regarding our next events, so in November, there will be 2 OPIN events. The first one will be about international collaborations. And in particular, this event will be organized and discussed with PLOCAN, the oceanic platform in Canary Islands. And then there will be another event on social acceptance mid-November. So you can already register for free on our website, in particular for the first one. And for the second one, registration will open very soon. Finally, if you're curious to know who are the 400 members of OPIN, you can check the members list on our website. You can also access the document section on the website. So here you can access in particular all the presentations from the previous events that we have organized, both workshops, masterclasses, etc. You can access the reports of our working groups. And we put here some other valuable reports that have been produced within the OPIN project. So obviously you can follow us on Twitter. I would like to stress that we have a LinkedIn group. So on the LinkedIn group, you can also directly exchange information between the OPIN members if you want to advertise some project, event, or if you have a specific request that you would like to be disseminated to the members, do not hesitate. And yeah, again, finally, if you have any question, don't hesitate to contact me or the generic mailbox of OPIN. So that's it for OPIN. Don't hesitate if you have questions. You can also put them in the Q&A box and I can answer them at the end of the meeting. Now I will give the floor to Michael and Joe from Renewable Risk Advisors. So guys, I will stop sharing and I give you the floor.
Laura, thank you very much. And hello, everybody. Thank you for joining us. You should be able to see the screen very shortly. Yeah, you can see the screen, Laura.
Yes, perfect.
Thank you. So I'm Joe Holm, and we'll hear from both of us shortly. First point to make is that this talk is about risk mitigation in title, but we want to broaden the context into the wider threats and the way to manage those threats. So you can avoid a risk by eliminating the cause of it, and you can accept a risk by laying a contingency plan. Mitigation is reducing the probability or the impact of a risk. And then there's transferring risk, which is where insurance comes in and plays a role in having a third party, that's the insurance company, to take on the responsibility for a risk. So brief introductions from us at Risk Advisors. So I'm Joe Holm. I'm a chartered marine technologist, and I spent the last 4 years in loss adjusting for offshore wind mostly, and also subsea cables, whereby insurance claims are kept ideally out of court and settled amicably, and projects got back on their feet. And you can have a great deal of privileged insight into projects when a loss has occurred and how the repair campaign is executed. Prior to that, I was a project developer for 8 years, mostly in tidal, both fixed and floating on both sides of the Atlantic, initially at Maygen, and then at Forth. Michael, are you with us to give your profile?
Yes, thank you, Joe. So I'm most of my experience has been on the insurance side of things, dedicated in the last 12, 14 years to renewables specifically, but with a brief foray working for an offshore renewable energy consultancy called Rework. So again, with some experience on the other side of the fence rather than just the risk mitigation side of things. Joe?
Thank you. So what do we do? 3 bullet points really: thought leadership, risk and insurance advisory, post-loss advisory. If you want to hear about the final 2, come and contact us direct. But for the purposes of this particular talk, we're going to explain what we did with the OceanSet project, funded via Ocean Energy Europe, ultimately by the European Commission, with regards to the proposal for establishing a relationship between insurability and bankability and ultimately investability, how solutions can be provided with public sector guarantees to enable greater scale and deployment of assets in initially wave and tidal, but also with application to floating offshore wind. So we'll expand on that further in due course. So this is a snapshot from February this year. This was a joint media launch between Ocean Energy Europe, ourselves and OceanSet, with regards to what we're trying to achieve. And this allowed us to attract a number of research informants to our study in order to establish an insurance fund that can enable warranty cover for technologies both within and outwith of UK waters, and providing export potential for EU projects. The proposed insurance and warranty fund, which is what we called it, called on a wide range of actors from both technology and project development, 29 of which we approached 17 wave power companies, and 11 companies responded and gave up an hour of their time through a structured interview process. And then all 100% of the tidal power companies that we approached engaged in our study, so 29 in total from industry. 13 expert organisations, and we'll come on to them. They comprise the potential members of the risk panel. They responded with their views and insights, and also supporting letters to our eventual report to the European Commission. And specialist insurers, mostly from the London market, but not only, but also a specialist insurance broker that had the knowledge of offshore wind and wave and tidal deployments in French waters, themselves being a French broker. We also approached lenders and equity investor stakeholders, so that's the ranges of finance, lenders of finance, and investors themselves. Just over 50% of those that we approached, I think it was 21 companies we approached, 12 of them engaged in our study, which is pretty good, but it's a significant shortfall from the other actors that we spoke with, which I think outlines the challenge ahead of simply engaging with lenders into the space of emerging wave and tidal, and we suspect for floating offshore wind once the risks become better understood. And then some initial interaction with the EU and EIP, and this is all in association with Mitigation. Michael, over to you on the outcomes of our study.
Yes, so essentially, it became very clear very rapidly that what most investors would require by way of third-party financial support, in view of their lack of understanding perhaps of those risks, was not available from the commercial insurance sector. Again, the lack of data, the insurers don't understand the risks either. So if we are to find a way of filling those gaps, we need to plug the holes with some public sector support, essentially. And we need to do it in a robust manner that doesn't unduly expose public monies. We've approached this in three strands. One being for the likes of decommissioning bonds, which are subject to similar root causes of the risks. If they're claimed upon, it's because the technology didn't work eventually and the project failed and so on and so forth. But at the moment, you just have to put all the money for the future decommissioning into a bank account in most instances, which is extremely poor use of investment funds and a very low return. So we're proposing there a pool which everybody, all the projects pay a premium into, and if it's insufficient at the end of the day, then it would require a backstop of a public guarantee, perhaps from the European Investment Bank, for instance. The second strand covers the risks of defect, machinery breakdown, things that would be covered under warranty or a broad insurance policy were it to be available, including the marine operations costs and the loss of revenue following downtime, where these are very much the areas where the commercial insurance sector is very wary about treading, and we're looking at creating a dedicated insurance structure, which I'll expand on briefly in the next slide. And then finally, we're looking to underpin this whole process with a panel of expert support for various reasons as a learning and information disseminating organization. Joe, could we flip to the next page, please?
Want to see the bar charts now?
Yes, please. So I won't go into that in detail because it's quite terrifying to look at, but basically this dedicated insurance vehicle is a series of protected cells, as they're called it. So in principle, each project would pay a substantial amount into its own cell, sufficient to cover what would be expected to be its exposures to all these perils. You'd have a maximum level of payout from the insurer for each project, depending on quite what was agreed at the outset. And the difference between that maximum exposure and the amount paid in would be covered by the public sector guarantor, which is still TBA and subject to discussions who might fulfill that role. But also, as well as that, there would be an underlying percentage risk sharing in each case. So this whole structure is really about allocating risk in such a way that it keeps everybody on their toes throughout, it keeps them aligned throughout, and that hopefully the red mark, which is the project contribution, is sufficient to cover all these risks in most instances, and the blue parts of the boxes being the difference between that and the amount that's required to give investors comfort is hopefully more a notional comfort level that the public sector would pick up. Through doing that, those public sector guarantees, a relatively small amount of guarantee could leverage very large amounts of extra investment capacity. Thank you, Joe. The third strand, this is not the complete universe of the expertise open to us. These are the specific respondents in the first phase of that survey who presented letters of support, and there are certainly other excellent organizations as well. But we do have a huge amount of expertise in the sector, most relevant in a presentation about standards and certification. All of these guys bring a huge amount to bear of learning from other projects, other industries and the like, and that it can create a very robust support mechanism, which on the next slide, please, Joe, we start to define some of the very high level what we'd be looking for these guys to do in conjunction with this project. This is at a slightly higher level. We expect the project themselves to have all sorts of risk management procedures and third-party advice in place anyway. This is more of an oversight, generally, is the idea that you can tick all the boxes that it's all in place, but do more than that to feed back, cross-fertilize, subject to confidentiality, cross-fertilize between projects, look at any opportunities for further savings and so on and so forth. And the exact extent of that will need to be defined in the next phase of the structure, which we're hopefully putting our minds to over the next couple of months, as well as trying to reach out to some of those parties to engage. So Joe, then that summary page is the next slide, I think, please. Yeah, so it's essentially what it's there for. To backtrack is to say, right, we've got potential exposure to the public sector monies with all these guarantees we're talking about. We need gatekeepers. We need people who can say whether the projects are robust, whether the previous demonstrations at scale at test sites are sufficient to give confidence that they'll survive at full scale in the sites they're going into now, and that they'll perform, and so on and so forth. It's then more than that, it's to kind of engage through the project to try and help them develop their risk management strategy, both for that project and for future iterations, further projects using the same technology. And as part of that learning process, it's to accelerate the confidence level of those insurers, and eventually therefore the investors and finance parties, who are going to be much more comfortable if we're generating the right sort of data, the right sort of proof of concept through all this. This panel should be able to accelerate that confidence building process and engage them through it. Joe, back to you.
Thank you, Michael. So just to recap, so the purpose of this risk panel is to protect public sector funding or guarantees, and the whole purpose of the fund itself, the insurance and warranty fund, is not so much to bring down the cost of insurance. It's more about widening the breadth of cover to make insurable projects more bankable, so that projects can raise the capital required to leverage available equity and make them ultimately more investable. Insurable, bankable, investable. And we believe that standardisation and certification will be critical to the work of the risk panel. So just a couple of slides on that here. So in demo, standardisation is all part of the industrialisation process, ranging from components to mooring system. And one example of quite a recent example of standardisation is on the role of the marine warranty surveyor. So the MWS has often been undefined or even not defined at all as to what the remit is, what the profile of an MWS might be. And I won't go into too much detail in this. You can refer to the slides later, or look up the Joint Rig Committee on MWS Code of Practice. But this does set some more standardisation in terms of the role of both the individual, but also the procedures, such as certificates of approval, both the issue and withdrawal of, and the application of COAs for both fixed and floating systems, and it also has a section on wave and tide. But with regards to certification, well, you'll hear more from Jonathan Colby very shortly. But we believe that certification is extremely useful, almost essential. We have placed some risks without certification, but the amount of rigor that the project developer has to go through is almost akin to getting type certification or project certification itself in the first place. The financial institutions recognise that harmonised standards of certification are very important to their decision making, and the conformity assessment under the IEC, we believe that's going to be very useful in applying certification to the insurance market, helping insurers and investors understand the risks as opposed to perceived risks. So we suggest that the risk panel for the insurance warranty fund engages with the certification process, and indeed that some of the members of the risk panel would need to be experts in certification in their own. So thank you all of you for listening, and thank you too to any of our clients listed here that are on the call. If any of you are interested in what we talked about regarding the Ocean Set report and what we're trying to achieve, please don't hesitate to get in touch with us directly. You've got our details there. Should you wish to help us take it to the next level with any kind of supporting letter or just words of advice to take us through the next stage gate of discovery. Thank you very much.
Thank you.
Thanks, boss. Thanks, Joe. Thanks, Michael. We had a couple of questions, so we'll address them during the last session. Now I will give the floor to Jonathan Colby from Verdant Power and also very involved in IEC. Jonathan, I give you the floor and I'll let you introduce the topic.
Thank you very much, Laura May. Thank you for the invitation. Good afternoon, everyone. Good morning from the East Coast of the US. My name is Jonathan Colby, and I'm the Director of Technology Performance at Verdant Power. And I currently serve as the chair of IEC TC 114 and as the convener of the marine sector of the IECRE. We'll talk today about those systems and those standards. Thank you very much to WEMEC for the invitation. Thanks, Laura May, and thank you to the Ocean Power Innovation Network for hosting these events. Let's get started. So generally today, I'd like to talk about the work and standards for marine energy. I'll talk about the work of certification for marine energy. And I certainly appreciate Joe and Michael's comments. I think they really led a nice segue into what I'm going to talk about here today. I'll give an example case study, if you will, of Verdant Power's application of an IEC TC 114 standard at our Roosevelt Island tidal energy site. And I'll end with some of the benefits of standards and certification to the industry at large, with a focus on improving confidence, reducing risk. As I think you all know, there's no shortage of terms around the industry and around the world for this industry. I'll use marine energy in general, and the work in specific at the IEC focuses on tidal, river, and ocean current energy, wave energy, and OTEC, or ocean thermal energy conversion systems. And I will apologize in advance for all of the acronyms. So as a bit of motivation, I certainly hope most people understand why standards are important. Standards in general ensure that a common language and best practice approach is applied, and standards and their adoption enable direct technology comparisons. But what makes an IEC, or an International Electrotechnical Commission standard, more relevant is that it is an international consensus-based standard, and we'll talk about why that's so important. I love giving an example of the benefit of standards, and I think one that's really tangible would be the light bulb. And I think you can see that with the standardization of that socket, the light bulb was able to go through significant innovation and significant energy efficiency and improvements, all while maintaining that common receptacle, enabling its adoption without any infrastructure updates. So for me, a really good example of the importance that standards can play in a global industry. So for marine energy specifically, the IEC established Technical Committee, or TC 114, for marine energy. The Technical Committee currently has more than 185 subject matter experts from 29 countries working on 19 unique working groups. To date, our Technical Committee has published 16 technical specifications. We have a 17th pending publication, and we have a number of our first edition standards that are in maintenance as we speak, preparing for a second edition. We have liaisons with a number of international organizations, as you can see here. As we look at the participating or P member countries, you can see that the largest global marketplaces for marine energy are represented as participating member countries. I think the gap in South America and certainly in Africa is clear, and we are working actively to engage and increase participation from these regions, as well as other countries that are not involved. We have 11 observing or O member countries, and you can see we do have Brazil as an O member country, so we are pleased to have some representation from South America, but we certainly are looking for additional representation in a number of the regions globally. The standards that we've published fall into two categories. Some of those standards are resource agnostic. And so you can see a list here of the standards that are independent of resource. Things like technology qualification, which Pilar will talk about, moorings, which Joe touched on, the physical design of your converter, which is the -2, one of our most fundamental standards. And then we have a suite of resource specific standards. In the -100 series, we see all of the wave energy related standards. In the -200 series, we see the tidal energy standards. In the -300, we see the river energy standards, and we see OTEC as the -20. Obviously, if anyone is interested to learn more about these standards, where to purchase them, feel free to contact me. And so with that, I'll transition to the conformity assessment side. And often the analogy is used that standards and conformity assessment are two sides of the same coin. And so ultimately, certification, which is the term for third-party verification, that certification to consensus-based international standards can reduce risk, it can improve market access, and it can support the commercialization of the marine energy industry. At the IEC, a third-party system has been set up called the IEC RE, where RE stands for renewable energy. This is the collaboration with 3 renewable sectors: marine, solar photovoltaic, and the wind sector. The system is broken down into 3 sector working groups. And in the marine sector, we have 6 member bodies. The fundamental outputs of the system include test reports and conformity statements, which form the basis of the certificates that Joe mentioned, such as a type certificate, a project certificate, etc. And now for the marine sector, the 2 main bodies that participate are renewable energy certification bodies and renewable energy test laboratories. And I'll talk a little bit more about these now. So here you can see the 6 member bodies that participate in the marine energy sector. And as we overlay that with the testing labs and certification bodies in each country, you really can see the breadth and depth of both testing and certification experience that are included in the marine sector of the IECRE. I highlight EMEC, who is the first accepted renewable energy test laboratory, and we'll talk about them briefly. And then I also highlight Lloyd's Register, who has recently applied for the first renewable energy certification body recognition. So both of those entities are taking the next steps in participation in the IECRE system. So I provide here, excuse me, some information. I'm glad to know, Laura May, that this will be shared. These links are active, so if you're interested in more information about any of this, please follow these links at your own leisure. I do also want to give shout outs to 3 recent and current testing and certification projects happening globally. I'm guessing many of you are familiar with the Met Certified project that just finished, the Encore project, that is its continuation, and then the TEAMER project, it's funded by the United States Department of Energy. So now that we've understood the background of TC 114 standards and of the ME certification systems in general, I wanted to give a formal and concrete example of how standards and certification work together. So here you can see a flow chart of the various steps that are necessary in the marine sector to achieve a type certificate. And as we overlay in green the TC 114 standards, you can see at each step in the certification process, there are specific TC 114 standards that map to the certification activities. And as you continue down that pathway, we continue to map the different standards as published by TC 114. And of particular relevance to Verdant Power and my words today are the -200 standard, which is the assessment of power performance for a tidal energy converter. And I highlight that in green here. So I want to go into a bit of a deep dive on the -200. For those who have never seen the standard, this is the cover page of the published -200. It was issued in May of 2013, and it has 6 major clauses that are required to verify compliance with the standard. On a technical level, the standard prescribes the location of the current profiler relative to the principal axis of energy capture. It provides guidance on how to analyze data across the disk of the energy extraction plane. It provides guidance on how to report on the tidal speed and direction as measured at the site of interest, all of which together feeds into the power curve. And so here you see on the y-axis, the mean power, and on the x-axis, the mean velocity. And for a developer like Verdant, this power curve and its third-party validation is a critical step in the pathway to commercialization, to improving confidence, and to reducing risk in the technology as it's being developed. And so to really retire risk in the performance of Verdant Power's technology, we successfully underwent a 3-year effort with EMEC to independently verify our compliance with the -200 standard using the certification system as developed under the IECRE. And I won't go through the details, but you can see that there is a significant amount of effort over a 3-year period to execute the first IECRE test report. We were quite proud. The standard requires a minimum 15-day and a maximum of 90 days testing with availability that must be above 80%. And during a 39-day period, we had nearly 100% availability and satisfied all of the data collection requirements in the standard. So this is a huge accomplishment for Verdant, but also on a standards and certification side, a huge accomplishment for both TC114 and for the IECRE system at large. And so really the last question is, why did Verdant choose the IEC? Why an Iecre Test Lab? Among a number of reasons, the main one, if I could bold why, would be that these Iecre test reports are a critical component in the certification process. And so as we work towards a full certificate of the Verdant technology, having these Iecre test reports is a significant component of that. And I noticed in one of Joe's slides that he mentioned that in certain cases, third-party verified certification products can act in the absence or instead of independent due diligence. And I do believe that issued test reports under the IEC are a great example of where these would replace the need and alleviate the need for independent due diligence by a third-party investor or insurer. Again, increasing confidence and reducing risk. So as my final takeaway slides, what are the benefits to the industry at large? You know, I truly believe that adoption of IEC standards and the third-party verification of compliance to those standards will reduce barriers to global market entry. They will improve insurability. They will increase access to funding and project finance. They will help ensure system performance. Ultimately, and I keep saying this, the goal is to reduce risk and increase confidence. And as a developer, we really want to enhance and increase the trust in our technology. And as Joe and Michael have described in this catchphrase, it's bankability, it's insurability, it's bankability, and it's investability. So I want to say thank you all. Again, thank you, Laura May, and I look forward to your questions during the Q&A session.
Thank you, Jonathan. Thanks for your detailed presentation. So now we will move on to our last speaker. I will ask Pilar Heras. She is head of certification at Floating Power Plant. So Pilar, I'll let you share your slides and I give you the floor.
Thank you for the invite, and thank you, Joe, Michael, and Jonathan for very interesting presentations, and they actually fit very nicely with mine as well. So I will skip some slides because they have been very well explained before. As Laura May said, I'm head of certification at Floating Power Plant. My background is in naval architecture and marine engineering. So as a naval architect, we are very used to following standards. So I am very pleased that I'm now in charge of using standards in the renewable energy sector. My presentation will be structured in 4 points. I will give you a brief introduction to the company. I will explain our technology, and I will give a brief description of how we approach technology qualification and what lessons we have learned. Floating Power Plant is a Danish company. We are an SME, so we are 14 people, but we work in collaboration with many other companies. As you can see, there are some of the logos. We have a presence in Denmark, where we are based. I'm based in Denmark, and then we have offices in the UK and in Spain, in Gran Canaria. We have also 3 project companies in the UK. And in the video, you can see our prototype that was deployed between 2008 and 2012 in Denmark. It was connected to an Ørsted wind farm, and it was the first device providing electricity to the grid, both strong waves and wind at the same time. It was just a demonstration platform, an R&D project. So the wind turbines were very small. It was 11 kilowatts each wind turbine, and it had 10 wave energy converters, but it was very useful to prove the concept. And it survived the worst Danish storm in the last 50 years, I believe. The technology is a semi-submersible platform that hosts a wind turbine. It can be scaled up or down to host commercial wind turbines from 4 megawatts to 10 or 15 when they come. It has 4 wave energy converters, so it has already been simplified from the prototype that we had before. And the wave energy converters vary from 1 to 4 megawatts, depends on the resource available. In addition, we are now exploring with some companies the inclusion of hydrogen production on top. The development of the company has been going on since 1995, where the inventor designed this platform with wave energy converter, and he got it tested in different wave basins. As I mentioned, we then built the first device that provided electricity to the grid, and this was in 2008. So there you have already many years of technology development. Sorry. Afterwards, with the lessons learned, we decided and we knew that we had to come back to the basin or to the design and redefine our numerical models and then start from scratch, basically. Because the technology worked, but we couldn't provide the evidence that was necessary to build confidence. So we asked partners and we asked customers, and then they have been driving our technology development. The technology qualification is part of the certification of a technology. As you can see here, this is from Lloyd's Register notes for technology qualification. And the first step, when you have a technology as complex as ours, you need to split in different subsystems. So in our case, we will have a wind turbine that could be considered a mature technology. And then we will have our wave energy converters and power takeoff that are less mature. So we will have to do a certification process on the wind turbine side, and then a qualification process on the wave energy converters and power takeoff systems, and then a qualification of the whole system. Different certification bodies approach technology qualification in very similar way. On the left-hand side, we can see DMV approach, and on the right-hand side, we can see Lloyd's Register approach. So they are very similar in the sense that they do a technology qualification, a technology assessment, sorry, that will be the technology appraisal for Lloyd's. And then they go to the technology qualification plan stage, and so does DMV, and then execution, review, certification, that would be qualification, execution, performance assessment of DMV. And this is the Iecre approach. Jonathan already went through it, so I will not spend much time on it. But my point here is that the technology qualification is very similar, and doesn't matter who you work with, in the sense that you can extrapolate the results from one to the other. So if you are short in resources, or if you have to tender out the process at different stages, don't be afraid of having to make a decision now, because then you can use your results. Doesn't matter who you work with. If that makes sense. For instance, we started working with Lloyd's Register a few years ago, and we went through one iteration of the technology qualification process. Afterwards, for another project, we had to tender out the process, and then we went with DMV. But the starting work packages were used from Lloyd's Register. So we didn't do the qualification basis again because it was already performed before. Then DMV follow up on that work. The examples of qualification activities that the floating power plant is doing right now, after addressing the challenges of our technology, as you can see here. In this matrix, it's very similar, the one for Lloyd's as well. You classify your systems or subsystems in new or unproven, proven or limited field history, and then in the experience. And then the red area are those that you should address first, in my opinion. We did a risk assessment of our technology, and we didn't get any new or unproven technologies, but we did get some limited field history bullet points. And those are the ones that we are addressing now. They are basically, we are focusing now on the numerical model and simulation tools and the power takeoff and wave energy converter. And for those, we are following as very useful documents, the IEC technical specification 61400 for floating offshore wind turbines. With those we define, we use those to check which load cases are more critical, so we can start planning based on those. And then the IECTS 62600-2 to design the wave energy converter. And specifically the -103 to design our test plan. The project is one of the qualification activities we are currently doing. Is a floating power plant is building the biggest wave energy PTO test bench in the world. This is going to be 250 kilowatts, and in size it will be like 5 meters tall. This project will upscale and complete the detailed design of a full-scale wave energy power takeoff, and the development and testing will result in an efficiency and cost-optimized PTO system. In this project, we are in the process of tendering out the technology qualification of this system, the wave power takeoff, and we hope that we can learn and we can build confidence and work on the design, because this one will be the same design that will go into our first full-scale device. And then as the second qualification activity, we are doing wave basing tests. As I said, we are following 62600-103. It works, you can get from there advice on the scaling, on the calibration, data acquisition, and reporting. It's very important to follow all the tests that they suggest. We have done operational tests, we have done survival tests, and then we have done short crested and long crested waves. And the inspection is being performed by Iecre because they have accreditation to inspect against IEC standards. We started doing testing in Aalborg University, but it was a very small wave basing. And then we moved to IHC Cantabria. We did a 4-week period testing in June, and then we are going there again for a second phase in March. So the lessons learned, and in my opinion, it's important to develop a qualification and certification plan as soon as you can. It's important to implement the plan and update it when it's needed. And it's, I will say that it's also important to, even if you're not being inspected against standards right now, it's still very nice that you follow the standards, because you can get inspected in retrospection. So if you follow the recommended practices and then you gather the data as they recommend, and then you write the reports and they recommend, that can count as a certification activity. Also, it's a very supportive community. So it's very good if you engage with certification bodies or people with experience in qualification and certification and share knowledge. I think people will save a lot of time and a lot of money if they join these sort of webinars and any opportunity that they can to share knowledge and help the industry to move forward. Because the goal, as I write there, is to de-risk the technology and to make it bankable. That's it. Thank you.
Thank you, Pilar. Thanks to all the speakers for your very good presentations. So now we have a bit of time for the questions. So we have already received some. I will give you a bit more time for additional questions to come in the dedicated Q&A box. Do not hesitate. So we'll start with the first question, actually for Joe. Do you believe that the difference between wave and tidal companies in responding to your request, 50% versus 100%, reflects the awareness of the relevance of insurance in both sectors?
Thank you, Laura, and thank you for the question.
Michael, would you like to take that one?
Yes, I'm happy to start. So on the numbers, it was 100% of titles. 18 out of 18 responded. Difficult to argue with that. And with wave, it's still pretty high with 11 out of 17. So I won't attempt the percentage for that. So it wasn't quite the difference that it may have come across as. However, there was a significant difference in uptake, and I believe this is due to the maturity of the respective asset classes. Tidal being closer to commercialization than wave at present, and I'm not saying that can't change over the next 5 years, especially with floating offshore wind getting access to acreage of seabed, and wave having a chance to co-locate with floating offshore. So watch this space. But tidal certainly is closer to market now. And perhaps the tidal power project developers have more focus on matters regarding insurability and, of course, bankability, as we've heard, in terms of rolling out a project at some scale to make it investable, whereas the wave developers are probably more focused on improving the technology rather than trying to bring a project to financial close of units. That's my take on it. Michael?
Yes, as a sort of average, I think that's correct. There obviously are some wave developers that are at an advanced stage of maturity themselves who are addressing these issues, but some of the others, perhaps the 6 out of 17 you mentioned there, are probably more still focused on design rather than commercialization.
Yeah.
Okay, thanks. Great. I see another question on your presentation. So, Joe, Michael, any thought on the classification rather than certification from your point of view?
To my simple mariner's mind, my first career was offshore merchant navy. The classification societies are focused primarily on survivability. Their business having stemmed from shipping from the very outset. Whereas certification has more focus and more granularity on the power curve, power performance, heard from Jonathan. So that's a simple take on it from me, Mike.
Yeah, and I wouldn't disagree necessarily, but in an ideal world, certainly with maturing technologies, so wave and tidal, and even things like floating offshore wind in the early stages, I think the insurers will be particularly focused on a sort of project certification process, which includes an analysis of the specific site conditions for a project, but also potentially as devices are being manufactured, fabricated in different environments increasingly going forward, that the certification process extends to the fabrication sites and things. So I think the need varies through time and maturity of a technology to some extent in terms of whether it's more of a focus on class or certification, but all is valuable, I think.
Or if I may add, I would just mention that the members of the Classification Society are often the same members that we describe as certification bodies. They are operating under 2 separate quality management systems. And I think that both classification societies and the certification bodies will offer similar quality in the process. And I know from the Iecre perspective, we're looking to make sure that both the traditional certification body and the classification society members can both participate in the activities of the system.
It's also worth noting that of the 13 respondees to our report with letters of support to the European Commission, for OceanSet. Of those 13, they included both classification societies and acknowledged experts in certification.
Okay, thanks all of you for your detailed answer to this question. I see now a question for Pilar. So thanks for your presentation. Did you experience any rework on the initial phase when changing certification body? And how did you address certification body IP when communicating the initial dossier, initial documents?
Thanks for the question. Did we experience any rework? Yes and no. When you change certification body, they quote you on what you ask for. So if you want them to review your previous documents, they will quote you for that. If you want them to review the documents and give you feedback and maybe review some new documents that may have happened in between because your work has been progressing in the meantime, they will quote you on that. So I wouldn't say that any rework was done. It's more like we use the previous work to build up on that. And then how did we address certification body IP? I don't know what IP is, but I will try to respond to what I'm
sure that's intellectual property, Pilar, is I believe what they mean.
Yes, yes, I confirm intellectual property when you communicated the documents.
Then you just sign an NDA in advance, and then you are free to share documents. And normally you will keep working with them later on. So it's, I think we have NDAs with all well-known certification bodies because we have worked with them at some point. So that will be the first step. And then from there, you share documents, you share knowledge, you hold meetings, and then they are very open to, at least in the renewable energy sector, they are very open to spend the time with you explaining the new processes that may appear and the new standards that are being developed. And then the quotes are very detailed, and then you just build a relationship from the very beginning with all of them.
Okay, thank you, Pilar. Another question here, I would ask Jonathan maybe to answer that one, and the other speakers can complement if needed. Increased certification inevitably adds cost, even though it should reduce risk. Is there not a danger that the increased cost will make it harder for inventors to test their systems at sea?
Yeah, thank you for that question. I actually think that it would make it easier to test by having that third-party verification. I think it will make access to funding easier. It'll make access to insurance easier. Oftentimes, it'll make access to the test site easier. For example, an independent test laboratory may mandate that you have some type of certificate, whether it's a technology qualification certificate like Pilar just described, whether it's a design assessment, whether it's some kind of electrical certificate guaranteeing either a power quality or a power performance. So I actually think without certification, developers may find it either more difficult and or more costly to do their testing. And yes, there is a cost with certification, but I think it is and I'm sure Joe and Michael can comment more on this, but I believe that that investment delivers a very real, return on that investment.
Yeah, thank you. I also appreciate the question because it comes to the point of what is the technology developer trying to achieve. If they want to deploy a single unit that's going to become a stranded asset that can't be rolled out because it's not bankable, then they can save money on things like this and get something in the water. But what are they going to do next? If you want to build out a project of multiple units that becomes a revenue dependent asset, can draw down on revenue per megawatt hour, and seek access to project finance to scale up, then the way to do that is to have the insurability, bankability, and therefore increased investability mindset in your head, rather than just pushing on technology alone, which will only take you so far. You need the market pull of sufficient scale, which, as with any infrastructure project really, requires project finance.
I'm sure that's right. The if you're about to deploy a unit that you know is really trying a few concepts and you don't expect it to be the same specification as the one that you're going to eventually commercialize, some shortcuts within reason are definitely acceptable. You still want to have an element of third-party sign-off on structural integrity, marine operations, and so on and so forth, but you might not need the full scope of certification that you will eventually need for the proper commercial unit.
Okay, thanks. We have another question here also on the, I would say, on the additional cost that could be involved by the standards and some particular requirements. So in particular regarding, here the example is taken for 100-year extreme event survivability requirements and safety factor, increasing the structural requirements as in the cost of marine renewable energy devices. It could be prohibitive for certain sectors, for instance, wave energy. So how would we deal with the huge uncertainty included in this assumption? And more generally, I would open the question to the uncertainty included in some assumptions in the standard. So maybe this is for you, Jonathan, and maybe also your feedback, Pilar, on this. How do we link the uncertainty in some assumptions in the technical specifications and related to the additional costs that it can involve on the structure?
Yeah, I'll be happy to make a comment here. From the Verdant perspective, we do have experience in this. Superstorm Sandy was a significant weather event in the New York City area that I'm sure most of you would know about some years ago. We did have sensors in the river during that superstorm, and we're able to actually collect data on what you might consider a 100-year extreme event. So I think the reason I tell that story is first and foremost is that data during operation and capturing more of the extreme events during long-term deployments is essential, and that data and that knowledge then feeds back into the standards through the subject matter experts. A little piece from Verdant's perspective also, we did include pretty significant safety factors to account for extreme loading. We measured some of those loads during operation and found that our safety factors were significantly conservative, which gets to the question I would say here. And we do need to reduce uncertainty in the environmental loading conditions to reduce cost of manufacturing, to make sure that we're not over fabricating and over manufacturing our products. And the sort of how to get it into the standards, I truly believe, is this iterative approach, much like Pilar described, where a developer uses the standard, takes that feedback and delivers it to the committee, where the subject matter experts can incorporate that input and that learning through that consensus-based process. And the standard grows as the industry grows.
Yes, I fully agree with Jonathan. In our experience, we didn't scale down the model in terms of structure. We did scale down the center of gravity, mass properties, and of course all the dimensions, but we didn't use the same structure philosophy, if you can tell. But that's fine. Then the report will just say that as well, that our geometry was scaled down in these points, and it was not following the full scale device in these other points. And it's fine. It's the same if you cannot complete all the tests that they suggest, they will evaluate you on those that you have performed, and they will ask you, why didn't you perform the other ones? Like if they suggest 15 waves and you only had time to do 10, they will say, okay, they completed these 10 as we suggest in the standard, but they are missing 5. So you just do what you can do following what they suggest. And then as Jonathan says, then they will take in the lessons that you learn, and they will, I hope that they will adjust in accordance to that.
Thank you, Pilar. Thanks, Jonathan. One last question I received in the chat for Jonathan. How can my organization be involved in the IC technical committees? So if someone wants to be involved in the technical committee
Yeah, and I'll explain maybe both sides. So that was for me, right, Laura May?
Yeah, it was for you.
Yeah. So each national country that participates is organized through a national committee. That national committee usually has an administrator, which is an organization. I know for a fact that in France, the organization administering that is Bureau Veritas. I know for a fact in the UK, the administration ordering that is BSI. And so depending on your country, you would work through your national committee to join the activities of TC 114. And then through your national committee, you would be nominated and appointed to serve on the different working groups of interest. Similarly, on the certification side, each member body has a national member body. And so you would work through that national member body to participate. I, as the chair, obviously have connections in each of these countries. So if you're not sure what organization runs your national committee, or you're not sure who the point of contact is in your region, please reach out to me and I'll make sure that I connect you with the sort of local leadership.
Thank you, Jonathan. Thanks to all. We are now at the end of the webinar, so thank you, everybody. Thanks for the detailed presentation from our speakers. Thanks for your questions, very interesting questions that we received at the end. I just put in the chat a link to the satisfaction survey. If you can take 1 minute of your time to fill it quickly, that would be really great to help us to organize other events and other activities for the OPIN members. So thanks again to all, and looking forward to meeting all of you in our future meetings. So there will be another one, actually 2 other ones in November, and some other activities within OPIN. Thank you. Have a nice end of afternoon. Bye-bye.